Back to Breakout. Just kind of poking around, looking at schematic. I broke down and took the time to make schematic sheets. I got the whole entire schematics out in sheets, and it's a good thing I did, because I started looking over the schematic and actually comparing it to the board instead of just poking around and doing things aimlessly. And I found a huge mistake that I made. A rookie mistake. I'm sitting here and I started looking at C6 right here, this guy, and I'm like, what is going on with this chip? Because everything around this chip seemed funny. First of all, I thought E6 on the schematic was C6 until I found out that the schematic was actually pointing to E6, not C6. So I was like, okay, well, I need to find C6 on the schematic. This flip-flop, 74. You can't really read that, but it's a 74. And I couldn't find this C6 74 on the schematic. I'm like, what is going on? I think the schematic's wrong. Right here is C6. Does that look like a flip-flop? That is an exclusive OR gate. That is an LS86. I got the wrong chip in the board. Good grief. So I'm going to replace that guy with an 86. Lord have mercy. Okay, I replaced and put in the proper chip right here. But I was having a problem with, every now and again, the screen would absolutely just flake out and it would skew and be all curvy and stuff. And it basically boils down to funkiness down here in the horizontal count. So I'm just going to do some maintenance here. I'm replacing all of the counts, all of the horizontal counts, and I'm replacing this 37. I actually have one of these, and I'm going to replace that because that is involved in making a inverted horizontal sync signal that feeds into this 175 that I've already replaced. So yeah, goofiness. So I'm going to just bite the bullet and replace this stuff down here. There's actually a counter right here too that might be the first count off the crystal. So I'm going to replace that counter too. I'm replacing all of them down here. Got the gun out. I'm getting ready. I'll be back. Okay, so I turned this thing on. I got all these chips replaced. Okay, and I turned it on and it looked great, and then it did this again. This is what it's been doing, and I'll show you exactly where the problem is. First off, let me get the schematic and then we'll look at that and I'll show you. Okay, here is this 175, and on pin 4 it gets the carry from K1, which is, well, it's right here. It's horizontal sync, and it gets the carry from that guy, and that's the Q on pin 4, or no, that's the data input on, yeah, that's the data input on pin 4, and then Q is pin 2, Q bar is pin 3, inverse. So let's look at this. This is J1, that's the 75, and the clear pin is always high, so it doesn't clear. And here is the clock, which is, it's really busy. And Pin 4 has the input. There's the input looking good. That's that carry bit. Q is pin 2. Looks good. And the inverse is that. Now watch, I'll jump start it. I'm going to short these two together. Okay, now I'm not able to jump start it. But I don't know if that's just a bad chip. That pin 3 comes off and goes to E2. This guy? E2? Is that right? And it says pin 3, E2, 12 and 13 out to 11. So 12 and 13. It says that goes into pin 12. Which, this is 12. And that don't look like... Oh no, this was replaced. Oops. The speaker's popping. That's kind of cool. Anyway, where was I? Kind of getting off track. Pin 3 of J1. Where does that go? Pin 3 of J1. It says it comes over and goes to pin 12 of, is that F2? E2? Pin 12, E2, F2? I don't know. Well, it's not F2. It's got to be this guy right here. The one with no marking. But you see pin 12 has a lifted leg and a wire going way over to here. To this 86. So could it be L2? No, that's not L2. I don't know. I gotta figure this out. I'm gonna have to do some beeping out, see what's going on here. I'll be back. Okay. Not H-Sync. The only place I've been able to find it, I didn't dig too hard though, is this 107 way up here. That guy. So I am going to replace the 107. That guy right there, because I think it's corrupting not H-Sync. And while my gun's heating up, I think I'll look around for that signal a little bit more and see if it goes anywhere else. Alright. Okay, I replaced the 107 and I took the liberty while I had the soldering gun out and I replaced basically everything up in this area. This is a 192 decade counter, which I don't have, but I did buy 5 of them with my order to Jameco Electronics. I pulled this out and I put it in my tester and it tested bad, the 192. So I'll have that coming. I just went ahead and pulled a 04 and a 00. They tested bad in my tester. Goodness. But anyway, now we're back to being solid. So that was obviously that 107 was creating havoc on this signal right here. And now our signal's back to normal, not horizontal sync. So, yeah. So now we're good. And hopefully solid this time. So now I am waiting on, I've done some work. I think I'm just going to remove and replace this guy when I get those chips. There's 4 of them on the board. I've already pulled 3 of them out. I might as well do 4. Might as well replace them all. I almost want to just replace every old chip on this thing, to be honest. I bought some of these RAMs too, because this output, if you remember, on pin 6 looks like that. It's half-ass dead. And what happens over time, I've noticed, is those bricks start to kind of disappear a little bit. They get smaller and smaller and smaller. That's all that RAM does, is that RAM is for the bricks. I do have some of these coming, and I am going to put a new RAM in there so that that output bit is less flaky. Yeah. All right. So we're back to solid for the time being until something fails. All right, guys. Guys, check this out. We're kind of getting somewhere. We got the ball bouncing around in attract mode now. Yeah, all right. And we can coin it. Boom. I just put a coin in it. Now I'm going to hit start. All right, now I've started. We got our paddle. And I will serve. Oh, look at that, guys. I'm playing Breakout. Oops. 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 And it goes back into attract. Heck yeah, that's exciting. We're getting there. Woo. Just wait for these last chips to come in. That is awesome. Put it on 5 balls. And I'm going to do it again. And boom. Oh. That sucked. See what I'm talking about? There's those RAMs. See how that's flaking? That's that bad RAM signal. But we'll fix that. We are getting close. All right. Well, I guess I will, you know what? I might just replace some more I might just replace some more chips. Some more simple logic. Some of the simple logic that's left on there. There's a few, maybe a couple 32s. There is maybe a couple more 00s, some 86s. I might just go ahead and replace all of these old chips that I can while I'm waiting for, just to renew it. I've already kind of fleshed out all the bad stuff. I kind of want to just replace everything. I mean, yeah, I don't know. I guess I'll leave it the way it is. I'll wait for the chips to come in that I'm waiting on. And that's really going to make a big difference, especially at 7448 that I've got pulled out of the board that had a ton of outputs that are just floating outputs now on the board. So we're close. This thing's close to working. You know, so I'm really excited. All right, guys, I'll see you back in a while. All right, one thing really quick. Remember how I talked about these counters where the reset pin was left to float? And I didn't like that. What I did here is I've put 1K resistors across the power rail to the reset line on all 4 of these horizontal counters, just to hold that reset high, because it shouldn't reset. That'll keep any kind of a power anomaly or anything like that from dropping that below the threshold, and these will reset. So now I have it to where you see they're held high. Those lines are now held high instead of floating. I don't know why that was done like that. It makes no sense to me. That reset line should have been held high. There's no reason for them to let it float. I don't get that. Kind of a design flaw, I think, to be honest. But now that's good to go. Like most of these, this is a counter right here too, and that one's floating too. I'm going to do the same thing to that one because it's also floating. See that? I'm going to hold that one high too. And see, here's a counter right here. It's floating too. All these counters, they got floating. Just don't understand that. If they don't want them to reset, they should have held them high. So any one of these that is floating, I'm going to put that 1K resistor across it to hold it high. Just wanted to kind of point that out. There's no point of having it completely disconnected. It's a reset line. If you don't want the thing to ever reset, it should have been held high. So it just seems like a design flaw to me, to be honest. So I'm going to go through all of these counters. I'm going to look at them, and if that reset line is floating, I'm going to put a 1K resistor across the power rail, just like this, on all of them. That'll make me feel better. Okay, and what I did here is I've already had replaced these 161s, and I threw a 163 in here. It doesn't matter. It can be a 161 or a 163 as long as reset is pulled high. They are exactly the same functioning chip unless you're having a reset pulse to them. As one of them is asynchronous and one of them is synchronous, meaning that one of them works without the clock. It does not need the clock, and one works in sync with the clock. The reset pulse, I should say. When a reset comes in, it does not matter what the clock is doing. With a 163, it will reset immediately. With a 161, it resets with the clock pulse once the reset comes in. So it's a timing issue. But since these are pulled high, it doesn't matter. So I've got the 1K, and I replaced this guy because it was an old one and I wanted to solder. I wanted to do that. So I was like, you know what, I'm just going to replace it. And I did. So I got a 163 here and a 161 here. And we're back up. See that right there? How that brick is kind of flaking out? That's what I mean by this RAM. This RAM is no good. It needs to be replaced. But while I had my desoldering gun out, I went nuts and I did this one, this one, this one, and this one. I replaced these 4 chips instead of just this guy. I was like, why not? So. Oh, and then I put them in my tester, and 3 of them tested bad. Just crazy. They tested bad, but I don't think they were actually bad. I just think that they were not what this tester was expecting somehow, the way that I really don't know. Because I don't think that they were actually bad, but whatever. Cool. Now these are all pulled high. It's not going to reset now because it's pulled high. No threat of reset. No more floating reset pins. all of these guys. No more floating reset pins. Breakout. And I know I just turned the camera off, but it was literally 5 seconds ago that I turned the camera off, and I just looked over here and turned it back on. See how these bricks are starting to disappear? That's what they're doing, is they're starting to disappear. And just in sections. It's that RAM. That RAM's no good. Yeah. Going away. Don't get too excited. This is the DICE emulator. It stands for Discrete Integrated Circuit Emulator. This is what Breakout is supposed to be like, look like. Now the color is color strips on the monitor, so this is actually, there's not color in Breakout. It's kind of weird that there's no bricks in the attract. I guess that's how it's supposed to be. It's hard to play this with all I have is the left and right controller. And that's it. But this is what it looks like, guys. I'm going to try one more game. See, now after you play a game, it's got the bricks in there for attract. That's kind of strange. It's odd. Ah. Oh, one more time. I can't end it like that. Oh, I moved away from it. We're breaking out of prison, guys. Oh. We're getting out of prison. Getting out of Shawshank. Oh no, the warden got us. We're done. Kind of cool. So simplistic, yet extremely challenging. Alright, well, something to look forward to, something to shoot for, a little inspiration to play the game here, and yeah, we'll keep at it.